Okay guys, so I'm going to go through a problem here where we're asked to construct a function. We're given, this is a drawing of an ice rink, which consists of a rectangular piece here and then two semicircles at the end. We're told that the width of the ice rink is X, and we're given some other information as well. We're told that the thickness of the ice, which I'm going to call D, the thickness of the ice, is 0.75 inches. And we're told that the length of the ice rink from here to here is 20 feet less than twice the width. So it's 20 feet less than twice the width. So that is to say that it is 2x, twice the width, minus 20. That is my length from there to there. And what we're asked to do is to construct a function for the volume of ice in the ice rink as a function of x, as a function of the width. So we want, as it were, v of x, the volume of ice as a function of x. And so in order to do this, what I'm going to do is I'm first going to find the area of the ice rink, the area of ice, and then I'm going to multiply it by the thickness of the ice, which again we are told is 3/4 of an inch. And so I'm going to find the area here of the ice rink as a function of x, and I'm going to multiply that by d, the thickness of the ice, and that will give me the volume. Area times thickness will give me the volume. All right, so to find the area, I'm first going to find the area of the rectangular piece here in the middle. So that is going to be 2x, that's length times width, so that's 2x, a of x, it's 2x minus 20, times the width, which is x. And so the area as a function of x, distributing in my x, is 2x squared minus 2x squared minus 20x. And that is the area of this piece right here. I should say that is the area of the rectangular piece. So maybe I'll just clean it up. That is the area of my rectangular piece right there. And so now I want the area of the two semicircles. Well, the two semicircles, in order to work out the area, I'm going to need the radius. I'm going to need to know that radius of the semicircle. And I can see that if this distance from here to here is x, then the distance from here to here must be x over 2. So this here must be x over 2 from here to here. And so that's my radius. My radius is x over 2. It is half the width. And so the area of the two semicircles, and I'm going to take them both together. So ultimately what I end up with is a circle, back two semicircles, as a function of x is going to be pi r squared. So it is pi r squared, or as a function of x, because r is x over 2, that will be pi x over 2 squared. And again, that takes into account both semicircles, meaning between these two I have the area of a full circle. Working this out, that becomes x over 2 squared is x squared over 4, which is, I'm going to bring my two constants to the front, pi over 4 x squared. So let's see, I now have the area of my rectangle and the area of my two semicircles here as functions of x. And so the total area, a of x, the total area, is the sum of these two. Right? It is the sum of these two, and so it is 2x squared minus 20x plus pi over 4 x squared. That's my total area. And so I'm almost there. To work out the volume then, v of x I just need to multiply a of x times d. So I need a of x times d. So that is 2x squared minus 20x plus pi over 4x squared, parentheses around this. I'm going to multiply this times d. Well, a word of caution, d is of course in inches, so I just need to be careful with my units here. X, we're told, is in feet. X is being measured in feet, whereas my distance is being measured in inches. So I'm going to convert inches to feet in that case. And so 1 inch is 1/12 of a foot. 1 inch is 1/12 of a foot. And I need 3/4 of this. So I need 3/4 or 0.75. 3/4 of 1/12. And so that will give me 3 times 1 is 3. 4 times 12 is 48. 3 over 48 is 1 over 16. So I have 1/16 of a foot. So I'm going to put that in here. Then instead, I'm going to replace that here for d. So that is 1/16. So I have a of x here, which I've worked out, times d. And I'm just going to distribute in this 1/16 into all of this. So I'll start, so v of x, start here at the first term, 1/16 times 2x squared. Well, 2 times 1/16, so that's 2/16. 2/16 is the same as 1/8. So that is 1/8 x squared. It's there to there. I want to go here to here. 1/16 minus 20x, so that's going to be minus 20 over 16, which is the same as 5 over 4. So it's 5 over 4, and I have an x. X plus, finally, pi times 1 is pi. 4 times 16 is 64 x squared. And that's it. That is my volume now as a function of x. And that's the first part of the question complete. We notice that it's a quadratic. It's a quadratic binomial. If you'd like, you could factor out your x squared term. You would have 1 over 8 plus pi over 64 times x squared minus 5 over 4x. And so, like I say, it is a quadratic binomial. The coefficient on my x squared term is 1 over 8 plus pi over 64. The coefficient on my x term is negative 5 over 4. It opens upwards. The coefficient on the x squared term is positive, so it's going to open upwards. But that's it. Either form is perfectly good. The next part asks us then to work out the volume of ice given the width is 90. In other words, we're asked to find V of 90. That's the next part of the question, find V of 90. And so simply plugging that in, I have 1 over 8. Maybe I'll use this form. You can use this form or this form. I'll use this second form here. 1 over 8 plus pi over 64 times x squared is going to be 90 squared. And 90 squared is 8,100. Minus 5 over 4 times x, and x again is 90. And so if you work all of this out, you find, take out a calculator, and you can work it out, and you will find that the volume of ice is 1,297.61 to 2 decimal places, and the units would be cubic feet. Cubic feet. That is the volume of ice that we're ending up with. And so that's that question completed. Part A and Part B. You formed the function, and you have found the value of that function for a given value of x right there.